Hello everybody. In this video we're going to implement a binary search and a bubble sort. I have a text file here on the desktop, and this text file has the following format. Has a list of countries, and each country has a country code, international country code, and as you see, the format is country code, then a bar character as a delimiter, and then the country name, and then here we have a new line character. So we're going to copy this file after we create the project. So I'm going to go to File, New. I'm going to create a project, and this is going to be console application and C++. And I already selected the directory where I'm going to store this, and I'm going to call this source code, let's say 02. This is going to be bubble sort and binary search. Okay, so we're going to let this thing do what it needs to do, and here's our source code. So let me make it a little bit bigger so we can see it. I'm going to get rid of this using namespace. I'm going to get rid of this too. And before we move on, I'm going to go to this particular project directory, plus exercises, and searching and sorting. And here's our searching and sorting. And as you see, this is our main. So from here, I'm going to copy and our data file, and I'm going to put it there. So here's our data file. So now we're pretty much ready to start working on this. So first things first, I need to have data structures to store my information, and I'm going to make two parallel arrays. So the first array is going to hold a list of country codes, and the second array is going to hold a list of countries. I don't know how many countries there are, so I'm going to take a guess. So I'm going to create a constant integer, and this is, I'm going to call it max array size, and we're going to make that, let's say 500. I'm just taking a guess. So this is going to be dimension of our array. Okay, and next thing we're going to do, we're going to declare here in the main program, we're going to declare two arrays. And since we're going to be using string, I'm going to include string, not stream buffer, but string. Okay, and then here I'm going to declare an array. So std, and this is of data type string, and I'm going to call it country code, and I'm going to say that this is of max array size. And we're going to work with parallel arrays, so I'm going to have another one, std size. Okay, so we have our two arrays. These arrays will hold the data captured from the file. Okay, so next thing I would like to do is I would like to declare also a counter, and this counter is going to tell me how many elements did the function that I'm about to write read from, how many countries and country codes there are. So it's going to be a simple integer, and I'm going to call this a counter, and I'm going to set it equal to -1. Okay, we can leave it as, but -1, I'll leave it as -1 so that we know if we're unable to read then anything from the file, then we know that code -1 means that we didn't read anything. Okay. One more thing that I need, I'm going to be using a file, so I need to include, and this is going to be fstream. Okay, now let's go and write the function. So this function is going to read data from the file. It's going to open the file, it's going to read all the data from the file, and it's going to populate the arrays. So if I'm unable to open the file correctly, then I need a code that specifies that I was unable to open the file correctly, and then I can display some kind of error message. So I'm gonna make this function return boolean, and I'm gonna call it populate arrays, and to this function we're gonna pass these two arrays. Now these two arrays currently have nothing in them. I could have initialized them like so to a empty string arrays, something like that. You know, we have, because right now we don't know what's in these arrays. We just allocated a block of memory, and you know, for all we know, there could be some garbage in it. All right, so populate arrays is going to take string array, so std of data type string, and I'm going to call it, arrays are, as you know, always passed as a pointer, or you know, if you will, since you don't know pointers yet, we haven't learned anything about pointers yet, I'm just going to refer to it as an address. Okay, so I do want this function to change the contents of this array, so I'm going to pass it without making it a constant. So this is, I'm just going to call it code, and I'm going to go to the next line so we see it a little bit better. I'm going to pass another array, also of data type string, and this is I'm gonna call this countries. Actually, let's just call it country, or codes and countries, whichever way. And the thing I'm gonna pass is an integer reference that's gonna tell me how many records did I read. So I need to know how many records did I read, because you know, we don't know. I'm just guessing that there's 500 countries in the database, maybe more, maybe less. All right, so I'm gonna call this num records or something like that, or num records read, or whatever. Okay, and this is the beginning and end of my function. So let me just make them line up nicely, and off we go by writing our code. Now, proper thing to do would also be to pass the name in the main program, to ask for the file name and perhaps even the location of the file in case we have the file somewhere in a different directory. But for the sake of simplicity, to keep number of parameters that are passed into the function to a minimum, I am just going to hard code the name of the file. Okay, so in this function, I'm going to declare a couple of local variables. One of them is going to be of data type is input stream, because this file is an input to our program, and I'm just going to call it ifile. And I'm also going to declare a boolean variable, and this is going to be file exists, something like that, and I'm going to set it equal to true. Okay, and I'm going to explain that in a minute as we go. And I'm going to also have a variable called index, or record index or record number or whatever you want to call it, and I'm going to set it to 0 since we have not read any records yet. Okay, so we're going to proceed by opening the file. Open the input file. We're going to process the input file. We're going to process input file, and then eventually we're going to close the input file, and we're going to return file exists. Okay, so I'm going to attempt to open this file. So it's going to be a file handle, so ifile.open, and like I said, I'm going to hard code this. So this is going to be countries.txt. And if this file fails to open, or if somebody moved it, or whatever happened to this file, so if not ifile, I'm going to set file exists to false. Okay, otherwise I'm going to proceed to process this file, meaning to read the contents of the file and to populate my arrays that I passed in. Okay, so let me copy this comment, let me put the comment in here, and I need to read this file for as long as there's records. So I don't know how many records there are, so I need to use something called end of file. End of file is a special marker. It's a while loop, so I'm going to say while and not ifile.eof. EOF stands for end of file, and let me fix this. We're going to read, and I'm going to use getLine. And where am I going to read from? The stream I'm reading from is ifile stream, and I'm going to store whatever I read into code sub I, or index rather. And the delimiter, if you recall, is this character, is the pipe character. Okay, so that is the delimiter in the file. If you look at the file here, that is what I'm talking about, this character here. If I open this file, this character right here. So we have code followed by this character, which is a delimiter, then we have country name, and then here we have invisible character, which is new line or form feed, and then your end of file would be right here. That signifies you know, that there's no more input. Okay, so we read that, we store it, and then the next read that we have, we're gonna read using getLine, and read using from ifile, and we're gonna store it into the country, also under same index, same location, except that this time I am interested in this character, which is new line character. Okay, so that is getLine for you, and then I'm going to, when I finish reading the first row, I'm going to increment the index. Okay, so this loop is gonna read until it reaches end of file. Once we're done with the while loop, at this point we can, that reference num records that we passed in is going to take on the value of index. So this way I know exactly how many records I read. So when I decide to print this, I don't need to guess how many records I have, or print, you know, 500, which is the dimension of the array. And what if I have only 12 countries in the input file? Then I would waste all that space from 13 all the way to location 500. Okay, so when I'm done with this, I'm gonna close the file. So let me be in line with the comment. Let me move the comment. Let me just cut it like so and put it here, and we're gonna close the file. So ifile.close, And then the last step that we have here is we are returning our Boolean variable. Now the way this works is, let me review the function. I'm going to make it a little bit smaller. We start by allocating local variables, and we assume that file exists there. Okay. If for whatever reason that file doesn't exist, we change this Boolean variable, this flag, we change it to false. Otherwise, we keep the flag as true. We process the file, and when we're done, we return file exists. And because file exists is, let's say we successfully process this file, then file exists is going to be true. If for whatever reason file was moved, we couldn't locate it, or I misspelled it or something like that, file exists is going to be set to false, and we're going to return false. Then in the caller program, in the main program, when I call this function, I can react to its return code. So this function is going to either return true or false. If it returns false, I'm going to display an error message. Okay, so what's left now for me is to copy this, which is our function header, and then to put it here. I'm going to declare this is going to be function prototypes, and I'm going to drop it here. Now some of you may want to keep the variable names, or you can delete them like so. I'm going to delete them just to demonstrate that you can do that, and it also is, gives us greater visibility, because the compiler doesn't care about the variable names. It just needs to know the type and the order. Okay, so now I would like to display what I read. So I'm going to write quickly write the function to display my arrays that are now located in memory after we've read them. So this function is going to be void because we're not going to return anything, and I'm just going to call it display arrays. To it, I'm going to pass both of these arrays and the number of elements that I've read, and I don't want this function to change the contents of these arrays, so I'm going to pass them as constant string, and let's be consistent, let's call it code. And also the other one is going to be constant std country, if I can spell it. And then I'm going to have a I can either pass it by value or as a constant integer. So if you want, I can pass it as constant int, and this is going to be num elements, or let's say array size. We know how many elements we have to loop through. Okay, so I want to print a header, for example, and I also want to use nice spacing. So we could just quickly do a IO manip, so pound include, and let's do IO manip. That's the header that's going to allow us to display a nicely tabulated data. So here all I'm going to do is display what's what, like column headers, like this is country code, and then this is the country name. So cout, and here I'm going to left oriented, so left, and then I'm just going to move to the next line so that's a little more visible. So here we're going to display 5, let's say width, set W is setting the width, and then here I'm just going to say code. Okay, then next to it I'm going to have std set W, and let's say we allocate 30 characters for country code, and this is going to country name, so this is going to be country name. And then finally we finish this with a set W, pardon me, we finish with the end line. Okay, so that's the header. That's just going to be column headers. And then what I'm going to do here, I'm going to have, I'm going to display the data from arrays. And that's going to be, I'm going to need a loop for that. So for integer I, we start at 0, I is less than array size, and I++. And then we're going to, I'm going to steal this like so we don't spend time typing, but be careful because this is where a lot of errors sneak in. So let me make sure that this is nicely, yeah, it is. And let's do it like that, or that it lines up nicely. I really like to have my code neat. So instead of country code here, instead of code, I am simply going to display contents of the code array. And then instead of country name, I'm going to display country and then sub I. Okay, so that is my function, display arrays. Let me copy the header and let me put it here in the header prototype section where the headers go. Let's Control C it. Let's Control V here, put the semicolon, and I'm going to be consistent. I'm going to get rid of variable names. Okay, so we are at the position now that we can test our program just to see if it works. So in the main, we're simply going to try to populate this array. So I'm going to test, because the function returns Boolean. So I'm going to say if not populate arrays, and then as you see, the editor is asking me, the compiler is asking me, what do I want to put in here? Actually, it's directing me to put the first parameter. The first parameter is code. Code is country code. Country code. Now this is an array. We just pass it like a variable. We don't need any special thing. And then the next thing is going to be country name. And I'm going to pass counter. Counter is the variable that I declared currently is -1. So if I get -1, that means I haven't read any records. I may have opened the file correctly. So as you see, I have I have double, you know, safe code, if you will. One, if something happens to the file, I'm going to pop an error message here. Actually, I don't need this because I can write it just in one line of code, but I'll leave it as a block. So here we're going to say std cout, and then we're going to say error, trouble locating file, trouble locating the file, and I'm going to do this in new line and say exiting. Okay, so that's all we want to say here. So std.endl. Okay, now otherwise, if I'm able to read this correctly, if I'm able to open the file correctly, if my counter is -1, that means I have not read anything else. But I'm just going to go and display arrays, and I'm going to do country code here, pass country code, and then I'm going to pass country name, and I'm going to pass counter. Okay, now I could test, I could check if the counter, I could put an if statement here and say if counter is right before this, right there, I could put an if statement. If the counter is equal to -1, then some kind of error message, and don't bother displaying array. In the interest of simplicity, I'm just going to leave it the way it is. So we're ready to compile this to see if it works. So I'm going to give it a build and run, and here I have an issue. I have single, this is a scope resolution operator, needs 2 colons. I have colon everywhere else, which means that I have it here as well. Okay, so let's try one more time. Let's see if I have, what do I have here? It says expected. So I have constant string, comma, constant. This needs a string here. This needs a data type. Okay. And let's try one more time. Better luck this time. Now here, I have an error here. It says country. Oh, std string. Same thing. I forgot the string. Okay. Now we should be okay. Let's see. All right. So here it is. It's printing all the countries. Quite a few countries that we have. And as you see, we have code, country name, nicely formatted. These are in, they should be in alphabetical order. Afghanistan, Albania, Algeria, and so on and so forth. Okay. However, the codes are not. The codes are not. So this makes a very good file that we can then take these codes and codes like so. And here I have position 0 or index 0, 1, index 2, and so on and so forth. And then here I have country names. So any change that I make to one of these arrays, I should make to the other array. Okay, because this is position 0, this is position 1, position 2, oops, 2, and so on and so forth. So here, let's say I have AF, which would be the first one, which is Afghanistan, and then here I have it Afghanistan as well, and it's spelled all the way. I'm gonna stop right here. So now if I was to swap these two, AF and AL, let's say for whatever reason I need to swap them, then I would need to swap these guys as well. So this is Albania, and then the next one is DZ. So see DZ, and then after that we have AS, which is AS is American Samoa. So this is Algeria, I believe, yes, Algeria, and then this is American Samoa. So if I was to order this array here, it is in alphabetical order. This one is not. Okay. Now demonstrate how your bubble sort and how your binary search works. Since this one is already sorted, we don't need to sort it. This one is not, so I'm just going to sort it by itself and therefore ruin the relationship that they have as parallel arrays. So I'm going to sort this using bubble sort, and then we're going to look for particular country code by using binary search. Binary search. Okay, so that is the plan. First thing I'm going to do is implement bubble sort. Okay, so bubble sort is very easy to implement. It is also very slow. It is not very efficient sorting algorithm, but this is what I'm going to do. I'm going to have a void, and then bubble sort, that's the name of the function, and I'm going to pass an array to it, and I want this function to change this array string, and we're going to give it a name. This is going to be just generic name ARR. We don't want to name it country or code or anything because it doesn't care. It's a string array. Okay, and I'm going to pass constant int, and this is going to be array size. We need to know exactly how many we want, and we can pass it as constant because that will preclude the function. That's very safe. Will preclude the function from making changes to that variable, or we could pass it by value. That would not affect the argument, meaning the original, but the function could still make changes to it. So, you know, constant int is a safer way to pass it. I need two loops. One loop is the loop for going from element to element and determining if I need to swap them, and then the other one is to loop through through the whole array to know when do I need to stop, when there's no more elements to swap. Okay, so bear with me for a second. So this outer loop that I'm going to create, this is going to be the loop that is going to go from element to element and see if I need to swap them. So I'm going to reverse loop. So bear with me. I'm going to say that for integer, and I'm going to call this max element. Now remember, array size is array start at 0, so array size is always 1 bigger than the size of array, so I'm going to have to subtract 1 from it, and then I'm going to say that max element is going to be greater than 0, so I'm looping in reverse, and then I'm going to say max element minus minus. Okay, and next thing I'm going to do, the inner loop is the one that's going to perform swaps. Okay, so this 0 and I is going to be less than max element, and then I plus plus, and this one is just gonna figure out if it needs to swap. Okay, now the way it's gonna figure out is gonna go and it's gonna say if array at index I is greater than array at index I plus 1, so that's the next one. If that condition is met, then we're gonna swap. We're gonna call a function that we're gonna write here. So I'm gonna put question because we need to write that function. Okay, so the way swap is gonna work is actually very simple. Let me create a new drawing here so we can see a little bit better. I'm gonna have a function swap, and to this function I'm gonna pass 2 elements. Okay, whatever these elements are, so data type, even if it's an integer or string. So in our case we're passing a string, and this needs to be passed as a reference or as a pointer. Okay, so string, let's say A, and then string B. This also needs to be a reference because we want to affect the originals. Okay, so there's going to be string B. Now the way this function is going to work, I'm not going to write the code here, I'm going to depict it. We have in the caller program, the one that's going to call has, let's say, x and y. Okay, and we're going to give some values to x and y. X is going to be, let's say, 10, and then y, let's give it y a 5. And the condition for me to swap them is if 10 is bigger than 5. So if x is greater than y, then I want this to become 5 and 10. Okay, now these are going to be 2 elements of our array. Okay, they are strings, and we want to pass them. So when we pass them as references, we're actually passing the location, the address of that. So when we swap them, we could potentially override. So this is what we have. We have, let's say, x or a has 10 in it, then b or y has 5. So if I was to take this 5 and assign it to 10, then 10 goes away and I have 5 and 5. So what I need to do is I need to introduce a third variable. So this is what's going to happen. I have my x, or a, whatever. A is an alias for x. Here we have 10. Then I have my b, and b has a 5. And then the next thing I'm going to do is create a third variable called temp. This is a temporary variable. So the first thing that we're going to do, we're going to say that temp takes on the value of a. So we're going to copy a here. So we save that value. Then we're going to say, that's the first step. We're going to say temp takes on the value of a. What that does, it copies contents of a into, this is my attempt to write the semicolon here, I apologize. So what it does, it copies contents of 10 into temp. Then we do this step. We say that that a takes on the value of b. So a takes on the value of b. So that means we take 5 and we copy it here. In the process, we destroy the contents of a, which was 10. So we now have 5 and 5. But lucky for us, we saved the contents of a into temp. So then the last thing that we need to do is we need to say that b is 10. And b becomes 10, so we have made the swap. Okay, so that's how swap function is going to work. All right, so let's do that in code. So this is a very, very simple function. I'm going to call it void. It's going to return void swap. Swap, there's a built-in function swap, but I'm going to call it swap elements since we're writing our own. And we have a string that we're passing, and it's going to be a reference. So I'm just going to call it a std, and this is also a string, and this is a b. And don't forget, this has to be a reference. And then we're going to do whatever we did in this little sidebar that we did. So let's declare a variable of data type string, not string buffer, but string. We're going to call this temporary temp. And we're going to say that temp takes on the value of a. Then we're going to say that a takes on the value of b. And then b takes on the value of temp. And we're done. Okay, so that is our swap. Let me copy the header, and let me put the header right here. And I am going to get rid of the variable names, like so. Okay, so we have that. Then the next step is to use this swap element inside of right here where I put the question mark. And that's going to be rather simple. We're just going to call that function. We're going to say swap elements, and as you see, the first thing that it wants a, so the first thing is going to be ARR, the first element, sub I. The second one is going to be ARR I plus 1. Done. Okay, so there's your swap function. So that's your bubble sort. Now let's copy the header of the bubble sort, and let's put it up here. Okay, now let's get rid of the variable names, and the only other thing that we have left is we have to now create a function that is going to perform binary search. Okay, we could test this. Actually, let's just do it. We display both arrays. Then I'm gonna do std, let's say cout, so we know that we finished this. This is just like a visual cue for us that we are done with displaying of arrays. And then here I could write the function, but this just for the debugging purposes, I'm going to write for int I, a quick way to display just a single array. I is less than counter, and then I++, and I'm just gonna do std cout, and we're gonna type country code sub I, and then std endl. Okay, so that should display a sorted list. We need to call, pardon me, we need to call here, I need to call bubble sort before this. So I'm going to call it bubble sort. What do I need to pass to it? This is country code array, and then I'm going to pass array size, which is going to be counter. And then this next line is just going to be for debugging purposes to see did we sort the array or not. Okay. All right, so let's run. So this is the first one, and as you see, these are all the country codes. So here I have see, notice that the first one was AF. If I go up, it was pretty long, huh? AFALDZ. Okay, so let's see if this is, so AD, AE, AF, AG. So see, now it's sorted. Bubble sort worked. Okay, and it was pretty fast considering that this is a quite large data set. Okay, so we know that bubble sort works, so we can get rid of this. So this was just, that was the purpose of that code. All right, so last but not least is to implement the binary search. And binary search, the way it works is it assumes that your data is or has been sorted, and then what it does, it halves the data set. So use the analogy of phone book, and when you're searching for certain values in it or target, and this is, let's say this is your array, this is your phone book, and here you have elements. Okay, so you have a bunch of them like so, and then this is your end. So what this algorithm does, the binary search, it needs to know the first, it needs to know the last element of your array, and then based on that it calculates the middle. This is your target string. Let's say this is a phone book and I'm looking for Michael Jordan. So it calculates the middle, and then it figures out what is here. So it takes this string that's sitting in here, and then it compares it to my target string. Okay, if I get lucky and I land right on Jordan, I'm done. Okay, so that's the best case scenario. If my middle means the location, the position, the index of the middle of the array, if the target string that's located in there pardon me, it is it matches my target string, I'm done. That's the best case scenario. Now if Jordan is larger, okay, then I am going to concentrate on this side of the array. If it's lower, then I'm going to concentrate on this side of the array. So then this becomes my last, let's say, and then this is my first, then I have that again, and then I assess again. Middle, is it larger or smaller than the target string? And then I concentrate either on this side of the array or that side of the array, so I get far fewer attempts rather than brute force. Recall that brute force would be testing each and every element of the array until the target string matches one of the entries in here. Best case scenario for brute force or sequential search would be that our target string is located in the first location. Worst case would be that it's located in the last element. Sequential search, recall, only works on data sets that, it works on any data set, but if you do not have ability to sort your data set, then you're stuck with your sequential search. Okay, Otherwise, the recommendation is to sort your data set and then use one of these methods like binary search to locate your target string much faster. This number of comparisons is worth it, because if it's something that is that needs speed, some kind of application that needs speed, maybe like in an emergency room or something like that, where you need to quickly locate your patient's record among 5 million records, then it is worth it. It is worth to have sorted data set. Okay, so let's go ahead and implement this real quick. We're going to implement it. This is going to return some kind of code, and that code is going to be the position, the index, the position of the target string. So this thing is integer because index is always an integer, and I'm going to call it binary search. So binary search. And in this instance, I do not want my function to change contents of this array. I just want it to look through it. So I'm going to pass an array to it, and I'm also going to pass array size. And the last thing that I'm going to pass is I'm going to pass the target string. Okay, so this I can pass either by reference, a constant reference, or by value. I'm going to choose now to pass it by value just to demonstrate that. And this is a string, and this is my target. This is the string I'm looking for. Okay, so let's declare some local variables. I need first, which is going to be the first index. So this is going to be a position of the first array element. Then I need integer also last. We start that it's going to be array size -1. Recall that arrays start at 0, so that's why we need this. So this is the index of the last array element. And then I need middle, so integer middle. Right now we don't have it as anything. If I don't, I could just leave nothing because we're going to calculate it, but I can initialize it to 0 either way. I can do this, doesn't matter. This is going to be calculated. So this is calculated midpoint. Calculated midpoint of every search. Midpoint of every search. Okay, then I also need the index. So this is going to be target position or target index, and I'm going to set it to -1 because right now, for all we know, that doesn't exist in there. So position or index of the target value. If we find it, it's going to be whatever the index is, whatever the position we found it in. If we don't find it, we're going to return -1. That way I know that we didn't find anything. Okay, and then last, what we need is a Boolean variable, which is, I'm going to call it found, and I'm going to set it to false because right now we haven't found it yet, and this is a flag that indicates success of the search. Okay, all right, so we need to loop now. So we need to loop until we find it, or until we exhaust all the tries. Okay, so since we don't know how many times we're going to go through, we're going to use a while loop. So while not found, and I'm going to explain this. This is first plus last, pardon me, first less or equal to last. Okay, this is necessary in case the second part, first less or equal to last, in case the target doesn't exist, the target string doesn't exist. Okay, so first things first, we need to determine middle, and middle is computed simply by taking the first plus the last. Notice that I have parentheses around it because of the order of operations. I want the summation to happen first. I divide it by 2. That's how I get my middle. And now I do testing. I say if my array at middle position that I just calculated, if I get lucky and that is equal to my target string that I passed in, I am done. So I can set found equal to true, and then I can say that target position is basically my middle. So I'm done. That's where I found it. So that's the best case scenario. That would be this scenario. If you recall from my drawing, that would be, let me select different color. That would be this. I was lucky, my target was right there in the middle. So I searched only for one element and I found it. Okay, highly unlikely. Then we need an else part, and here we're going to test if our array submiddle is greater than the target. Okay, so that means this. That means if this element here, whatever we found in it, is greater than the target. Okay, so I'm looking for Jordan and I landed on S, Scott. Okay, so that is greater than the target, so that means that my that I need to search this side of the array. Okay, so in that case, the last is middle minus 1. That's going to be middle minus 1. So back to the picture, I was here on the middle. I determined that this is S or Scott. I'm looking for Jordan, so I am not interested in this part of the array. So my middle, I go one less, I make that my last, so this is now my last. So as you see, I have basically cut out half of the data set, so I know that my answer, that my target is going to be somewhere here. Okay, so that's all we do here. And then the next step is the other case. So otherwise, if we land, then our first is going to be middle plus 1. Okay, so suppose that, you know, my target was smaller. My target was bigger than the middle. That means I discard this part and I make my first is not here anymore. My first becomes right after the middle, becomes this guy here. And then I'm interested in this part of the array. I don't change the last. Okay, so that's what this does. And I keep looping and doing this until I find what I need to find. Okay, so when I'm done with my while loop, I just want to return the target position. Target position. Okay, so this means if found, return the index of the string that match the target. Otherwise, -1. Okay, that's it. That's your binary search. Very simple. All right. So hopefully it makes sense. And let's just copy this header, and then let's put that. Oops, did I copy it correctly? Let's copy it. Let's put the header here, and I'm gonna put semicolon. I'm gonna get rid of these things, variable names, and then let's test it. That's the only thing we have left. We need to test this. So what I'm gonna do is after I do this bubble sort, I'm simply gonna ask the user here. I'm just gonna say std cout, enter the country code. And I'm going to read that into some variable here. So I'm going to call this std. That's the code for country. And I'm going to read whatever the user enters. So I'm going to use getLine, and I'm going to read it from cin stream, and I'm going to store it in C code. Okay, I'm not doing much error checking here. And then I'm going to also have an integer variable result, and I'm going to assign that. I'm going to assign to result the return value of the binary search. So binary search, I'm going to pass the array to it, so it's going to be country code, and then I'm going to pass the array size, which is the counter, and then the target is going to be C code, this one that we captured from the user. And then here, based on this code, we can say if result is equal to -1, then the cout, and we can say C code is not in the data set. Okay, otherwise std cout, and we can say C code, C code, and we can say exists. And then to demonstrate how this works, I'm gonna say that this is country code sub result, because result is gonna give me the correct, and they should match. std endl. Okay, that's it, we're done. So I could have also, instead of result here, I could have just called this function like I did here. So I didn't really need to introduce the result variable. I could just say if binary search equal, and with the whole thing call it equal to -1, then do this, otherwise do that. Okay, we're done. Let's compile. Let's see how this, and here what do I have? I have constant something inst, constant int, not inst but int, constant int. Okay, let's try one more time. Let's see, hopefully that's it. Here inst needs to be int. Okay, let's try one more time. This looks good. Okay, so it prints all that, and then enter country code. So I'm going to purposely enter country code that I know doesn't exist. So it's going to be ZZ. Okay, and it says ZZ is not in the data set, so that works. Let's run it one more time and let it finish this. And now let's enter one, let's say ls. Oops, where am I? Let's go ls. Oh, ls is not in the data set. Huh. I need to see why. Let me try one of the first ones. Let's say AF. Let's try the first one. Let's see real quick. So we do that, and let's say AL. Okay, I have a slight issue here, so that means I have some problem in my binary search. So let's take a quick look at it. Let me try to figure out what is going on here. I have first plus last, and I divide that by 2, and if it's equal to target, I say found is true, target position is middle. I also have if it's greater than target, last is middle -1, otherwise first is middle +1. Okay, so that looks good, and then I return target position. Do I pass this correctly? I do. Send in the string, which is target, and as long as it's not found and first is less or equal to last, and I set the found to false, and first is 0. That's the problem. First needs to be set to 0. First was some garbage. That's why this happened. Okay, let's try one more time, and let's try country code. Let's say TT. Okay, TT exists, TT. Okay, so that was the problem. The problem was that first had some garbage in it, and that's why it was not finding anything. Okay, so I hope this helps, and let me know if otherwise. Thank you.